Hello viewers, friction question 1. A large box of mass 25 kilograms is dragged across the floor. The static coefficient of friction between the box and the floor is 0.4 and the kinetic coefficient of friction between the box and the floor is 0.3. First task is to find the minimum applied force required due to friction, and that is given by the force due to friction is mu, the coefficient of friction, multiplied by the normal force. Until we get it moving, the object is static, which means it's the static coefficient of friction, namely 0.4, which is required here, and the normal force is the force going to be the same as the force due to gravity here, because there is going to be no vertical acceleration, which means the forces acting downwards, which is gravity, must be equal to the forces acting upwards to ensure that it has vertical equilibrium. So the normal force in this case is the same as the weight force, which is 25 times 9.81, and that is 98.1 newtons. Okay, so the force due to friction is 98.1 newtons. Part B, what happens if a force of size 80 newtons is applied to the box? It won't move because not enough of a force is exerted to overcome friction, so it doesn't move as the force applied is less than 98.1 newtons. So that's not going to move there. However, in question C, we've got a 110 newton force applied, and we're assuming that the force is exactly horizontal here. We're not looking at forces at an angle just yet. The force applied is purely horizontal. 110 newtons is greater than 98.1, therefore it's going to move. And we need to find the acceleration, which means we'll need to use Newton's second law here. Force net, which is the mass times the acceleration, is the sum of the forces. So let's take the forwards direction to be positive, so it's going to be forces going to the right minus forces going to the left. So the force going to the right, first of all we've got mass times acceleration, is, let's say we're pulling or pushing the object to the right, so forces to the right would be 110 minus forces to the left. Now we've got to be careful here, because the force applied is more than 98.1, it's going to start moving. And because it's moving, it is now the kinetic coefficient of friction that applies. So this forces to the left is a friction force, but due to the kinetic coefficient of friction, which is now 0.3 multiplied by the normal force, which is still the same. It's only accelerating horizontally, nothing's happening in the vertical direction. Okay, so we've got mass times acceleration, and we can divide that by the mass, which we know to be 25, so we get 110 minus 0.3 times 25 times 9.81. Calculating that gives you 73.6, just that part. And divide that by the mass, which is 25. So 110 minus 73.6, so that will be 36.4, and we're dividing that by 25, we get 1.46 meters per second squared. Thanks for watching, over and out.